We're here at gotomath.com. We're working some calculus, and we are in the section continuity and one-sided limits, and you want to click on this button here to see this problem. And of course, this up here is a chat box that you can chat live with me if we're going to experiment with that and see how that works out. Okay, so how about we just get the whole chat box? We might have somebody actually say something here. Where are we at? Let's go to the board and let's get busy. Now this one here is, I think the reason I put this one in the problem set is because I think a lot of students or whoever's studying this stuff, you might be confused on this one, and if you see this on a quiz or a test, so that's the reason that I put this on here. Now, if you just follow the steps that are taken to what the definition of continuity is, and actually I need to read this. So we want to find this A that makes h of x continuous on the real number line. Alright, so that's what we're looking for. Forgot the question. Okay, so to test for continuity, we need to test some things. First off, let's find h of a. Now, this is where it's interesting right here at a. Alright, so we're going to do that. H of a is equal to, now we can't use a up here because x, the domain of this particular part of h of x, right, says we can't use a. But we can use a here. So when we plug a in, we get 12 out. Alright, and then we're going to do the limit as x approaches a, right, we're approaching this number here, and so we're going to use the x squared minus a squared over x minus a. Now, when we did evaluating limits analytically, we came across this a lot. We do the direct substitution, plugging a in, you get a squared minus a squared, and that's 0. And a minus a, that's 0. So we got 0 over 0. That's not good. So we want to factor. Let's try factoring the numerator. And it will factor to x minus a. It's a difference of two squares. And x plus a, and it's all over x minus a. We can rewrite this limit as x. Okay, now as you can see here, this and this will cancel out, and we can rewrite this limit. And actually, these limits are all equal, so how about we just write it right here, x plus a, since it's equal to our original limit. Now we can go ahead and do the direct substitution. We have plugging a in for x here, and which is left with, we can simplify that to 2a. Now remember, for once we find this and then we find the limit, okay, this and these two things have to be equal to each other in order for it to be continuous at a. So what we want to do is just set them equal to each other. It's that simple. Therefore, we could say that a is equal to 6. Alright, so we found our a was equal to 6, and that's it. That's all you got to do. So we go back. We don't hit video because we're making the video, right? And so what you want to do is click on 5 and practice this problem. Practice, 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 practice makes, well, I don't know if that's perfect or not, but you get the idea, right? Okay. Did anybody send us any messages? No, it doesn't look like it. So get on here, leave a message. Tell us how this is hopefully helping you out or how we can improve. Of course, there's lots of improvements that can be done here at this website. But right now we got problems, we got video help, and some problems, if we could see this button to the far right, it says help. Some of them actually explain it out. And